No, there's a link to it on the website page, and it's really, my username on YouTube is Waller is me. Because after a while, that's been taken. That's been screw it, Waller's me. Okay, that works. Would you like to be Waller 87? No, I don't want to be Waller 87. Let's see, where do we go? Number 9. So force of 20 pounds directed at an angle of 60 degrees above the horizontal. Thank God. Okay, that's good. 20 pounds. Has the horizontal component of what? So of course the horizontal component in this case, of course as almost always, is the x-axis. X likes, or what likes x? So cosine likes x. So 20 cosine 60. Cosine of 60 is 1/2. So that's 10. So it should be part A. Real quick. Since cosine likes x, the closer my angle takes it to the x-axis, the bigger cosine gets. I didn't memorize cosine of 30 and sine of 60 and all that shit. I don't have that much space in my head. What I think is, that's far away from the x-axis. Cosine should be small. Sine should be big. Right? So that must be where cosine's 1/2. Sine must be √3/2 because it's getting really close to where it likes it. Right? That makes it very simple to remember. If you're already going to memorize, cool. If you don't have them memorized and don't have a way to know them, not a good place to be. Right?
You can use your fingers.
Go back. Yeah, I've seen that too. It's been a while since I
Bend it anywhere on top is cosine, anywhere on the bottom is sine.
freaky. I like it. I like this here too. Sine is 0 here, right? So I can say 0 over, go with me now. This will be √1/2, √2/2, √3/2, √4/2, which is 2/2, which is 1. So this would be like √0/2. And there's the pattern there, right? Have you guys ever seen that? Okay, cool. Some of you guys have, some of you guys haven't. If you don't like that at all, never use it. Right? Number 10, that's the one that gave us a lot of trouble, and somebody pointed out that technically they give me the answer if you want to look at it now. The answer is fine. But number 10, assuming that they mean that the boat is traveling and then the wind starts, what will its speed relative to the shore be? So it's moving east at 5 miles an hour. And then we'll say a wind starts. And in this particular problem, they don't ask for direction. So it doesn't, you don't have to be super perfect here. But from the north means, of course, it's pointing south. So this will be, what was it, 5√3. So I already have an expression for the velocity vector. The velocity vector of this boat would be -5√3. Do you guys see that? There's the x piece, there's the y piece. Pointing down, so I called it negative. Okay, did you have to know that for this problem? No. But it makes the next step easy. If it wants to know the true speed of the boat, that's just the length of this vector. So it's just really doing Pythagorean theorem to figure out, here's where it's really going to go. We put the components together to figure that out. Yeah?
Maybe this isn't a big point. Do you do tip to tail? You drew your second vector from the same point.
Yes.
I thought you only do that when you're finding the difference between. Didn't you teach us last class?
Doing a parallelogram.
Yes, cool, exactly. Because normally, and again, a lot of what I do, just my last degree was physics, so I often think about physics in my head when I'm doing this. And whenever you have several forces acting on something, you point in the direction that the effect it would have, right? So even though it's coming from the north, I'm going to point starting here that way, because it's kind of like making that move this way. Does that make sense? Hopefully. Now, it's a good point, though, because if you don't draw your picture correctly, it's very visual problems. You're not going to do the problem correctly. Right? Question? Yeah?
When it says coming from the north, does it mean it's pointing south?
Beautiful. Coming from the north, so it must be, you know, if that's north, if that's north, then if it's coming from the north, It's gonna push me south. I like it. Again, in this specific problem, direction wasn't part of the question. So you should end up, when you do your Pythagorean theorem, you should end up with the same answer, which was 10. So answer B. There's something else I wanted to show you. I forgot. Oh, too bad. It'll come back to me over the break. So let's go ahead and take a break. Come back at quarter till.
What if the air resistance is going the opposite way? What if the air, is going the opposite way?
Oh, that's what I wanted to say. No. What I wanted to say was how to figure out the direction. But if you put this going this way, right?
Say like, you have the plane going east and your wind going south. Is that east and west?
East and south.
Sorry, if you're going east and you're going west.
Oh,
no
I see. Then it definitely matters because they should cancel each other out in some degree,
If
right?
it's a natural,
Not cancel, what I mean is they should have to not to work, so it should, once you cancel part or more than the whole thing of the other, right?
so is that subtracting vector?
It ends up being subtracting vectors. One will be positive.
That would reduce the magnitude, right?
Yeah, magnitude by itself is not enough, we know that, because the direction, which often is denoted by a negative positive in a lot of problems, because
Divide by 5.
in most problems, you're really only worried about up and down, for
like
example. Right? I drop something, it's going down, the force of the wind is up, so it's got different things going on there, but, so negative positive very often only talks about direction, right? So I define down here to be negative. It really wouldn't change anything if I turned it around. As long as I was consistent, if suddenly I had something going up, it better be positive, right? Yeah. So just, so you can catch up with video or get notes from somebody else.